FileWeaver, flexible file management with automatic dependency tracking. We are interested in how knowledge workers, such as scientists, track, maintain, and refine complex information. We interviewed 23 scientists from various disciplines, including mathematics, biology, and computer science, and identified 6 themes. They use different supports for their information and transfer information across these supports. They hoard information, just in case they need it again, and develop personalized strategies to refine this information. They go through a repetitive produce, communicate, reproduce cycle, and have limited ways of expressing dependencies across files. Based on these findings, we introduced FileWeaver, which automatically detects dependencies among files, records their history, and visualizes dependencies in history in interactive graphs. FileWeaver helps users keep files consistent with their dependencies, refine related content, and easily share files and their dependencies. We present 4 use cases that illustrate different features of FileWeaver: maintaining dependencies across files, abstracting file formats via polymorphic files, navigating histories and managing file versions, and sharing files. Use Case 1. Maintaining dependencies across files. Jane adds the LaTeX file main.txt to FileWeaver and then adds the files linked to it. The file and its linked files appear in the graph view with an animation. She then adds a Python script. FileWeaver runs the script and adds the generated PDF file. Jane manually connects a README file to the main LaTeX file. She edits the LaTeX file to add a figure and is prompted for a commit message. FileWeaver automatically updates all dependent files and opens the resulting PDF file. The new figure has been added. Jane opens the original folder of the Python script and edits it to change the color to green. After saving it, FileWeaver runs the scripts, updates the linked files, and opens the updated PDF. Jane tags the README file with a new name in the graph view to facilitate finding it later. Use Case 2. Abstracting file formats via polymorphic files. Jane opens the folder of an image file and sees 4 variants of the same figure. She merges them into a polymorphic file, or morph. The graph view connects the variants with blue lines. Jane collapses the morph to simplify the graph and reduce clutter. When she calls the morph from the Beamer file, FileWeaver automatically calls the preferred extension. Jane expands the morph to check which variant was used. Use Case 3. Navigating histories and managing file versions. Jane opens the history of the main text file. She first opens a previous version and then selects 2 recent versions and displays their differences. Jane creates a copy of the file with its linked files. In the graph view, a green arrow links the original to the copy. She updates the files linked to the copy. She first edits the copy and sees the result. She then edits the original and checks the result. When she opens the history view, she can see the branch with the original and the copy. Use Case 4. Sharing files. Jane wants to share all files related to the main text file with Alex. She selects Flat Archive, which gathers all relevant files into a single folder. In order for Alex to run the project, Jane must create a runnable archive that also copies the hierarchy of folders. This lets Alex directly edit and compile these files. In summary, FileWeaver connects interrelated files, file histories, and existing tools to help knowledge workers manage the lifecycle of their documents. Thank you.